Hello and welcome to this session. Here we shall discuss few important problems from application of trigonometry. That is application of trigonometry. This is a very important and surely you are going to get few questions from this part. Especially in the application of trigonometry, we shall deal up with height and distance problems. This is very important. Now, the basic things what one should understand is, if we consider this is a ground level and this is the height. This can be anything, the height of a building, height of a flagpole, or anything. And suppose here at the point A, observer is there and he is looking at the top of the building. Observer is at a lower point and he is looking at the top. This angle is angle of elevation. Elevation. This angle is the angle of elevation. So these are few terms which are related to this application. Another situation can be, if this is the ground and this is a building and the observer is at the top of the building and he watches a car coming on the road at B, then from the top point he is looking at the lower point. Again this angle, now with this reference, will be known as angle of depression. This is angle of depression. Now, one thing should be very clearly noticed, that angle of depression and angle of elevation are exactly the same and are made with the horizon, but the reference is with respect to the location of the observer. Let us understand through some examples. Let me take one question. Find the height of a flagpole. Flagpole. If the angle of elevation is 30 degree and the distance of flagpole from the observer is 150 meters. Now see, we have to find the height of the flagpole. Now suppose this is the ground and this is a flagpole. We have to find, say this is the height h. If the angle of elevation is 30 degree, from where the distance of the flagpole from the observer is here. From here, the angle of elevation, the top, is 30 degree and this distance is given to be 150 meters. Now we have to find out height of the flagpole. Very clearly, if I label it A, B and C, BC is the height of the flagpole. Let us solve it. In triangle ABC, tan 30 degree is opposite on adjacent. Now the value of tan 30 is 1 upon root 3 is equal to h upon 150. This implies that h is 150 upon root 3. Rationalizing, multiplying by root 3 and dividing by root 3, which is nothing but 1, we get 150 times root 3, and this root 3 will become 3. By 350 goes 50 times. So this is 50 times root 3 meters is the height of the flagpole. Is the height of the flagpole. So this is our answer. Now this way there are a number of problems, and surely one problem is going to come from this part. Let us consider another question. The angle of elevation, again it is angle of elevation, that means observer is at a lower point of a ladder against a wall is 60 degree, and the foot of the ladder is 9.5 meter away from the wall. Find the length of the ladder. Now in these questions it is very important to understand the language and draw the diagram accordingly. Now here, suppose this is the ground and this is a wall. A ladder is supposed to lie against the wall, and it says the angle of elevation with the wall, angle of elevation of ladder, this angle is 60 degree, and the foot of the ladder is 9.5 meters away from the wall. Suppose A, B is the wall and this is the foot of the ladder C, right? So what we have to find out? We have to find the length of the ladder. Suppose length of the ladder is L. Solution. Let L be the length of the ladder. Now in triangle ABC, sine, not sine, cosine 60 will be adjacent upon the hypotenuse, that is 9.5 upon L. Now cos 60 is nothing but half. We are supposed to remember the value of standard angles which we have learned in the previous session. So this half is equal to 9.5 upon L, On simplifying, it gives L is equal to 9.5 times 2, which is nothing but 19 meters, is our answer. So this way, what we have seen in these questions, it is very, very important that we should understand the language properly and draw the diagram correctly. Once the diagram is drawn correctly, the question will be solved very easily. It is simple and basic. Let me take another question. An electric pole. An electric pole is 10-meter high. A steel wire tied to top of the pole is affixed at a point on the ground. To keep the pole upright. If the wire makes an angle of 45 degrees with the horizon, find the length of the wire. Once again, as I told, we have to understand the language and draw a correct diagram. An electric pole. So this is the ground and this is the pole. In order to support the pole, there is a steel wire. Say AB is the pole and this AC is the wire which is affixed on the ground at a point to keep the pole upright. Now if this wire makes an angle of 45 degree with the horizon, that is the ground, find the length of the wire. Say length of the wire is L. So let us solve it. Let AB be the electric pole and AC equal to L be the steel wire. Now in triangle ABC, electric pole, the height of the electric pole is given 10 meter. Now this is opposite to this angle and this is hypotenuse. So this, in this case, we will take sine of 45 degrees is equal to opposite upon the hypotenuse. This sine 45 is 1 on root 2, that is 10 upon L, implies that the L is 10 times of root 2 meters is our answer. So questions are very simple. The only challenge is you have to understand the language and draw a correct diagram. Let us take another question quickly. The length of a string between the kite and a point on the ground is 90 meters. If the string makes an angle of theta with the ground such that tan theta is 15 upon 8, how high is the kite from the ground? Assume that there is no slack in the string. There is no slack in the string. Now here, suppose this is the ground, a point, kite is flying, say kite is at A, this is the point on the ground, and this is the height of the kite from the ground, AB, and this is the point C where the observer is. No angle is given here. The length of the string is given to be 90 meters, and this angle, we don't know the angle, but tan of theta is given. Theta is this angle, and let us solve it. Let A C B the string equal to 90 meter, and AB the height of kite above the ground. And angle ACB is theta. Now tan theta is 15 upon 8. We know tan theta is nothing but opposite by adjacent. We have to find AB. So this is here EB is 8AB is 15 BC. In triangle ABC, by Pythagoras theorem, we know AC square is AB square plus BC square. AC is 90 square is equal to AB square plus BC. BC is nothing but 8 on 15 times AB square. This will become AB square taken common, 1 plus 8 square is 64 and 15 square is 225. Now, on further simplifying, we get AB square is 225 plus 64 upon 225, which is nothing but 289 by 225 times AB square. Now, from this, we get AB square is 90 square into 225 upon 289. I can write it as 90 square into 15 square upon 17 square, or this can be written as 90 times 15 upon 17 whole square is AB square, or AB is 90 times 15 upon 17, which on simplifying gives 1350 upon 17, that is 79.41 meters is the height of the kite from the ground. This is our final answer. Thank you very much, and we shall discuss some more questions in the sessions to come.